Hey there, tech enthusiasts. Welcome back to Linux Cloud Hacks channel, where we explore the latest and greatest in technology. In today's video, we are diving into the world of object storage with MINIO, a high-performance S3-compatible object storage system. I'll be showing you how to set it up using Docker, how to connect to it, understand what object storage is, what bucket is, how it all works, how to upload and download data, and so on. Finally, I will demo how to secure it with TLS and expose it to the internet using Cloudflare tunnel. So, let's get started. First thing first, what is MINIO? MINIO is a popular open source object storage server compatible with Amazon S3 cloud storage service. It's perfect for storing unstructured data like photos, videos, log files, backups, and containers. It's designed to be minimal and efficient, making it an excellent choice for storing data. Now you may be wondering, why use MinIO instead of Amazon S3? Here are a few reasons. 1. MinIO is free and open source, while AWS S3 charges based on the amount of storage and bandwidth you use. MinIO allows you to manage your storage cost efficiently by hosting it on your own infrastructure. 2. With MinIO, you have complete control over your data in infrastructure. You can customize the deployment to meet your specific needs, which isn't always possible with Amazon S3. 3. Hosting your own MinIO server ensures that your data stays on premises, which can be crucial for meeting data privacy regulation and protecting sensitive information. 4. MinIO is optimized for high-performance object storage, and since it runs on your hardware, you can fine-tune the performance based on your requirements. 5. MinIO provides S3-compatible API, so if you are already familiar with AWS S3, you'll find it easy to transition to MinIO without changing your existing applications. MinIO offers various deployment models for storage solutions. The simplest option is a single node with a single disk, which doesn't provide any redundancy or fault tolerance. Next is the single node with multiple disks setup, where your data is distributed across multiple disks, allowing it to withstand one or more disk failures depending on the configuration. For higher resiliency, there are multi-node, multi-disk clusters that can handle node failures and even whole site replication scenarios for maximum fault tolerance. I will demo more complex setups in one of my future videos. In this video, we'll get you started with a single node, single disk installation using Docker. If you haven't got Docker, don't worry, it's super easy to set up. You'll find installation instructions in the video description. Let's begin by accessing our server and creating a Docker Compose file to define our application. First, we need to configure a volume. We'll name it MinIO data. This volume will be used as a backend for our storage service. Remember, MinIO does not work on raw block devices, so the mount point needs to have a file system. For production, it's recommended to use XFS formatted drives. Next, in the services section, let's define the MinIO service. For this demo, we'll set the image to the latest version. However, for production, you should lock it to a stable version to be in control of the upgrades. We'll also specify a custom container name to avoid relying on Docker auto-generated names. To access the application, we need to expose two ports. Port 9000 for the primary S3 service, which will be used by any S3 compatible client, and port 9001 for the optional web GUI. In the environment variable sections, we need to define the superuser name and superuser password. Then we'll bind our MinIO data volume created by Docker to the /data folder inside the container. Finally, we need to specify a command to run after the container starts. We want to run a server where the data is stored in /data and the web console listens on port 9001 TCP. Let's save the configuration, and that's it. See how easy that was? To start the container in the background, we'll use the command docker compose app-d. To validate that the MinIO S3 service is operational, I will check the logs. Everything looks good. Here we can see the API URL and the web GUI URL. Let's double check if the ports are forwarded so we can access the container from the outside. Everything looks good. I will note down the IP address of the server 192.168.10.230. As our service is up and running, it's time to connect to it from a remote client. I will use my PC, which is on the same local network. To access your object storage, you need an S3 compatible client. This could be AWS S3 CLI, WinSCP, FileZilla, CyberDuck, or any other application that supports S3. Today, we'll use MINIO default command line interface MC. First, let's download the latest MC client binary from the MINIO download page. Next, let's grant execute permission and move the binary to the USR local bin folder. With the client installed, the next step is configuring the connection to the S3 service. We'll use the MC alias command to manage server credentials. To add a new server, we'll use the set command followed by the server alias. Since you'll be connecting to multiple S3 servers, choose a meaningful name. I will name mine MINIO admin to indicate that's an administrative connection to the server. Then let's provide the protocol, IP address and port the service is listening on. Note that the protocol is HTTP, so the connection is not encrypted. We'll address that later. The port 9000 is for S3 access, while port 9001 is for GUI access. Finally, let's provide the username and password that was set in the Docker Compose file. With the new connection setup, we'll list the connections with MC alias list. The configuration is stored in the .mcconfig.json file. For a final connectivity test, we'll use the mcadmin.info command followed by the configuration alias name. This command connects to your MINIO server, authenticates and provides basic information like server uptime, version, nodes, drives, and server pools. In this tutorial, we are going to avoid using administrative privileges for day-to-day tasks by creating a regular non-privileged user. To start, let's execute the mcadmin user add command followed by our configuration alias. This is because every MC command requires us to provide the alias so the client knows which server to connect to and what credentials to use. Then, there's the username and password. Great, our user has been created. Confirm, let's list our users with the mcadmin user list command. Remember to specify the configuration alias each time. There's our user. Now we need to attach a policy to our user. Policies define what actions a user can perform on specific resources. We can create custom policies or use predefined ones. Let's list the available policies with mcadmin policy list. Next, let's look at the specifics of the read-only policy. If you are familiar with AWS S3, this is the same policy template. If you see this document for the first time, it has several sections. The policy name, which you can customize, the version, which should not be changed, the effect, allow or deny. The list of actions, mind the actions are related to S3 storage and the resources, in this case, all S3 buckets. This read-only policy grants read permissions to all S3 buckets on the server. Let's check out the predefined write-only policy next. The main change here is the action type, which for write-only is set to S3 put object. This allows us to upload new objects to the S3 bucket, but not create new buckets. For this tutorial, we'll use the read-write policy. This is a comprehensive policy that allows all actions on S3 buckets. We'll discuss what a bucket is in a moment, so hang tight. Next, let's attach the read-write policy to our user. We'll execute mcadmin policy attach, specify the policy name read-write, and then the user we just created. Now, let's check the policies assigned to our user. Remember, a user can have multiple policies attached. Perfect, our Philip user has the read-write policy assigned. Finally, it's time to connect to the MINIO service using our newly created user. We'll use the mcalias set command, name the connection S3, and provide the new user credentials. If we list our connection aliases, we'll see both the admin connection and the regular connection to the server. Let's try getting information about our MINIO service using the regular user by selecting the S3 connection alias. As expected, we got an access denied message. This is because our policy allows us to perform all S3 related operations like creating buckets and uploading data, but not administrative actions like creating users or querying cluster info. And that's it. You have successfully created a non-privileged user and connected to the MINIO service using that user. You've been hearing about buckets, so let's dive into what they are. A bucket, specifically an S3 bucket, is a storage container used to store objects. These objects can be files, images, videos, documents, backups, and more. Each object consists of data itself, metadata, and a unique identifier. We'll explore this more in the video. Buckets are designed to offer high scalability and durability. The MINIO service also provides features like access control. For example, user 1 has full access to the bucket, user 2 has read-only access to the bucket, user 3 does not have access to the bucket at all. Storage service also supports object versioning. You can have multiple versions of a file in a bucket. Object locking, so files cannot be removed for a specific period of time, for example for compliance purposes. S3 storage also supports lifecycle management for automatic archiving, moving data to different tiers, or removing data. You can define a rule that, for example, removes files older than 30 days. In this video, I will show you a few basic properties of S3 object storage. First, it's a RESTful-like API, meaning it uses HTTP method like get, put, and delete to interact with resources like buckets and objects. Yes, you interact with your storage using HTTP, with all its benefits like TLS encryption, multi-part uploads, caching, and so on. Enough of the talking. I will start by running a man-in-the-middle proxy. This interactive HTTP proxy is ideal for sniffing the HTTP protocol. Next, let's set the HTTP proxy environment variable to the proxy, which is listening on localhost port 8080. This will cause all S3 requests to go via the proxy. Obviously, you should skip these steps. I'm just doing that so later I can show you what the protocol looks like. Let's create our first S3 bucket. I will use the mc make bucket command, followed by the server alias. We'll use S3. Then provide a slash the bucket name. Okay. Our first bucket has been created. To list the buckets and objects on our server, we'll use the mc list command. Our first S3 bucket is there. Note that the bucket name is unique within our MINIO deployment. If another user tries to create a bucket with the same name, it will fail because the bucket already exists. In AWS or GCP, bucket names are unique globally. Next, let's create a file named file1.txt with the content file1. Then let's copy the file from our disk to the newly created bucket. We'll use the mc copy command, provide the file name, then our server alias, followed by the bucket name. I will list the contents of the bucket with mc list. Our file is there. Do you see how easy it was to create a bucket and upload a file? Almost as easy as copying the files locally. Now, let's display our file contents using the mc_cat command. We'll provide the server, bucket name, and the object identifier, also called the object key. This key functions like a file name within a directory structure. It uniquely identifies the object within the bucket. In other words, you cannot have two objects with the same name in the same bucket. Additionally, the object identifier, along with the bucket name, uniquely identifies the object within the MINIO deployment. Let's create another file named file2.txt. Then let's copy it to the bucket, but this time we'll add a folder called prefix after the bucket name. Now let's list our bucket contents. Here's the file name and here's our prefix. If we perform a recursive list with ls-r, we'll see two objects. One object key is file1.txt and another object key is folder/file2.txt. Note that S3 doesn't have a hierarchical structure. Slashes in object key simulate a folder-like path for better organization. However, these slashes don't create actual folders. They are simply part of the object key string. Moving further, we can copy a file from the S3 bucket back to our local storage. We can also copy or move files between buckets. Let me create a new bucket named bucket2. Then I will use the mc move command to move the file from bucket 1 to bucket 2. If we list our MINIO storage, we'll see two buckets. each bucket with a single file. Now let's quickly switch to our proxy. Here's our bucket creation. It was an HTTP put operation with the bucket name provided as the path. If we look at the request, we'll see the authorization header. This allows the MC client to provide credentials to the server to prove its identity and gain access to protected resources. Then here's the HTTP GET operation, which was our request to list all buckets. The slash means all. If we look at the resource, there's our bucket 1. Here we push a file with HTTP put. The target location is the object ID file1.txt within bucket 1. If we look at the request, we find the file contents in the body. There's also a chunk signature. S3 compares that hash to ensure all chunks were uploaded correctly and no data corruption occurred during the transfer. Every request also has an authorization header. Here we get the bucket 1 contents showing the bucket name. If we look at the response, it shows the object counts, key names, modified dates, and so on. Lastly, we fetch the file from the bucket. Here's the URI and the response body showing our file. Now that we have some fundamental knowledge about S3 buckets, let's discover a few more of its properties. One of the great S3 features is atomic uploads. This means that the file upload operation must complete successfully before the object is made available in the bucket. If an upload is interrupted or fails for any reason, the particular uploaded file is not visible. Moreover, for large files, S3 supports multi-part uploads, which allows you to upload a single object as a set of parts. Each part is independently uploaded, and only after all parts are uploaded successfully, the parts are combined to form the final object. During the multi-part upload process, incomplete parts do not appear in the bucket. Lastly, the MINIO provides read after write consistency. This means that after a successful write of an object or an overwrite or delete of an object, all subsequent read requests will immediately return the most recent version of an object. This is true even in a distributed setup. This is critical for database backups, static web hosting, and data lakes and analytics. Let me show you that incomplete uploads do not show in the bucket. First, let's create a 10 MB file. Then let's start the upload of the file to the bucket 1. Mind that I've added a limit upload parameter that caps the upload speed to 100K per second. There's also a limit download parameter that you can set. While the file is being uploaded, let's go to another console and list the contents of the bucket. Do you see that? The incomplete file is not showing in the bucket. Let's switch back to the upload and speed up time. Okay, upload has completed. If we list the bucket now, the file is there. There's also one more parameter related to data integrity. Let's list our objects in JSON format. That's the entity tag, ETAG for short. For single part uploads, that's basically a MD5 hash. For multi-part uploads, the value calculation is a bit more complex. ETAG has few key functions. First, it uniquely identifies the content of an object. When the content of an object changes, the ETAG value also changes. Secondly, when you download an object from S3, the downloaded object ETAG is recalculated and compared to the ETAG stored with the object on S3. If they match, it indicates that the object hasn't been corrupted during transfer. Lastly, ETAG helps in caching mechanisms by allowing clients to determine if the content has changed since the last retrieval. At the beginning of the video, I've told you that object has data, metadata, and ID. Let's play a bit with metadata. Each object, each bucket, can be assigned multiple tags. A tag is a key value pair that you can attach to an object or a bucket. Tags are not stored within the S3 object data. They are stored as metadata associated with the object or bucket. Tags allow you for flexible categorization of your data. Let's first set the tag using mctag set command, followed by the file name. We'll tag file1.txt. I will set a custom tag. Let's say the owner is Philip and data is important. You can name your tags whatever you like. Let's tag file2.txt. This time I will set the owner to Mike and data to not important. Now let's check file tag with mctag list. The data tag is set and the owner tag is set. Now the fun part. Let's search all the files in our MinIO server with the owner tag set to Philip. Here's our file 1. Now let's search for files with the owner set to Mike. Do you see how powerful that is? Tags provide a way to add an extra layer of meaning and classification to your data without altering the object contents itself. Of course, MinIO has very powerful searching capabilities. Apart from metadata, size, name, date, you can even search by regular expression. After that short introduction to the MC CLI interface, let's go to the MinIO GUI. I will enter the IP address of the MinIO server, but this time on port 9001 TCP. I will log in as admin. Here are our two buckets. Let's go to bucket 1. Here are the files we did upload via CLI. Let's try downloading file 10. I will select the file and then click download. There you go. The file has been downloaded. Now let me try uploading a file to that bucket. I will select upload, then upload file. Bam! A file has been uploaded. After selecting the file, I will find all the information. Name, size, modification time, ETAG, tags, and so on. Let's click on the preview. You can do that for known file types. Nice. Let me add a tag. I will select tags and set the owner to Philip. There you go. The tag is set. Now, I will go to buckets and select create new bucket. Let's name it bucket 3. I will set the quota to 1 GB. This is a limit of how much data can be stored in a bucket. If I click on that bucket, I will find its various properties. Let's go to Object Browser and select bucket 3. Let me upload the same file again. Now I will click on the file and select Share. This will generate a link that's valid for the amount of time specified here. In our case, let's leave it at 12 hours. This link allows people to download this file without the need to authenticate. Let's copy the link. I will now open the link in another tab. There you go. The file has been downloaded. For our storage solution to be fully operational, we need two things. One, expose it to the internet. We want to be able to access our data from anywhere in the world, unless you are building an internal-only air-gapped cluster. Second thing is TLS encryption. We want the network connection to be encrypted. If you have a public IP, the easiest way is to build a reverse proxy. For example, Nginx with Cerbot for Let's Encrypt certificates. If you are interested in how to do it, let me know down in the comments. If you don't have a static public IP, you can use a tunnel. That's exactly what we'll be doing today. We'll set up a Cloudflare tunnel that will provide the public TLS endpoint and proxy the traffic to our Docker container. Tunnel software will be running as a Docker container. It's not the best approach, as with Cloudflare free tier, you can only upload 100 megabytes in a single HTTP post. That will limit your maximum upload size to a few hundred megs with multi-part uploads. Let's start by going to our server and opening Docker Compose file. First thing we need to do is add the MinIO browser redirect URL environment variable. We'll set it to https s3 console linux cloud hacks OVH. That's the URL our MinIO console will be listening on. Then let's add Cloudflare service. Provide the image for Cloudflare D, host name, container name, restart policy, and command to run at start. In the environment variable sections, we need to define tunnel token. We'll get it from the Cloudflare console in a sec. Some prerequisites. You need to own a domain. You need to set Cloudflare DNS to be the DNS for your domain. You need to register with Cloudflare free tier and Cloudflare Zero Trust. You can check my other videos on how to do it. I will go to my Cloudflare console. Let's select Zero Trust, Networks, add a tunnel, select Cloudflare D and click Next. I will name the tunnel MinIO and click Save. Let me copy the authentication token and paste it here in the tunnel token field. It's time to start our Cloudflare tunnel. I will run docker compose app-d. Okay, it's up. Our tunnel is showing as up. Let's click Next. Here we need to specify which endpoints should be proxied to our MinIO server. First endpoint will be the S3 endpoint that should be redirected to our MinIO Docker container on port 9000. Let's click Save. Now we need to add a second endpoint for the GUI. Let's click on the MinIO tunnel, then Edit, Public Hostname, and add a public hostname. I will name the domain as S3 console and redirect it to our container listening on HTTP port 9001. Now we have two public endpoints, S3 Linux Cloud Hacks OVH for the S3 access and S3 Console Linux Cloud Hacks OVH for the console access. To enable HTTPS, let's go to the main menu, then Websites, select our website, then TLS, Edge certificates, and select Always use HTTPS. This will cause all traffic to come via HTTPS. Cloudflare will terminate all HTTPS traffic and route it via the tunnel using HTTP. For the S3 endpoint to work, we need to disable caching. Let's go to Caching, Cache Rules, create a rule, name it MINIO, select hostname and put S3 Linux Cloud Hacks OVH, and then the action is bypass. Okay, we are ready. Next step is to test if the solution works. It's time for the final test. I will add a new connection with MC alias set. Let's name it MinIO public. We'll set the protocol to HTTPS and then specify the DNS name we've defined in Cloudflare. Mind that the port is 443. Cloudflare is terminating the HTTPS connection on port 443 and redirecting to port 9000. Lastly, let's specify the credentials. Let me check if it got added correctly. Okay, looks good. Let's test the connection with mcadmin info command. Works. To show you that the traffic indeed goes via the internet, I will issue mcping command. Yup, the latency is 70 milliseconds. It's definitely not local network. Let me open the web browser and enter S3 console address. I will log in as admin. Then let's go to bucket 3, select our object, click share. Do you see the URL? It's public, it's HTTPS. We can share it with anyone on the internet. Let's copy the link and open it in new tab. Works. And there you have it, folks. We've successfully installed MinIO using Docker, created and managed buckets, uploaded data, and exposed our MinIO instance to the internet using Cloudflare. MinIO provides a robust, cost-effective, and flexible alternative to traditional cloud storage solutions like AWS S3. If you found this video helpful, please give it a thumbs up. Don't forget to subscribe to the channel and hit the notification bell so you never miss an update. I have lots more exciting tutorials and tech tips coming your way.